So welcome to this video. We'll begin over the Cambridge International A-Level Maths, October-November 2022, Pure 1, Paper 1, Variant 1. Let's go. So first question, just a nice one. We just need to solve this equation. 3x plus 2 is equal to 2 over x minus 1, okay? So how we're going to start? Well, we're just going to bring the x minus 1 to the other side. So we have 3x plus 2, x minus 1, and then that is equal to a 2. And then we just need to expand the brackets out. So we get a 3x squared, then we get a minus 3x plus 2x, and then we get a minus 2, and that's equal to 2. Okay. And then at this stage here, if we bring everything to the left side and simplify down, we get a 3x squared. Then we get a minus 3x plus 2x, that's a minus x. And then we get a minus 2 minus another 2, so that'll give us a minus 4, and that is equal to 0. And at this stage, we just have a quadratic equation here. So if we do the brackets, well, we know one will have to be a 3x, the other will have to be an x, okay? We've got 3x squared. And then we got a 4 and a 1, so we've got to think about which factors of minus 4 would give us a minus 1, okay? So we got 2, we can either do 2 or we can do 4 and 1. So in this case, a 4 and 1 would do it, okay? So now it's just about figuring out what ways do I need to make everything to give me exactly what I want. So in this case, it would be a minus 4 here and a positive 1 here, okay? Because now if we was to work this out, well, we would end up with a 3x times a 1, which is a 3x, and then a minus 4 times an x, which is a minus 4x. Then that 3x minus 4x gives us the minus x, and then we have the minus 4 times 1, which also gives us the minus 4. So we factorized it, and now at this stage, we can just work out our x value. So we know x is equal to a 4 over 3, and x is equal to a minus 1. So for this one here, we have the equation of the curve. It's just that dy over dx is equal to 12 times by 1 over 2x minus 1, and that is all being raised to the power of minus 4. It's given that the curve passes through the point P, which has coordinates of 6, 4. We find the equation of the tangent to the curve at P. In this question, we're working out the equation of tangent to a curve at P. So that's going to be an equation of a straight line. Therefore, we need to know our x, our y, and on our m value, okay? M would be the gradient. So we know our x and y. We know that if it's the curve at P, or the tangent to the curve at P, we know that our x and y values will just be 6 and 4. And we just need to work out our m value now. Now we've been given dy over dx, so if we just put in our x value at that point, well, that will give us our m value. So that's what we're going to do. So in our case, that'll be 6. So we just need to do 12. And then in brackets, it'll be a half times 6 minus 1, and that'll be raised to the power of minus 4. If you work that out, you get a 12. Then in brackets, you get a 3 minus 1 to the minus 4, which would be a 12. And then that will be in brackets a 2 to the minus 4. If you work that out, you get a 12. 2 to the minus 4 is a 1 over 16. So then we end up with our m value being 12 over 16, okay? And that simplifies down to a 3 over 4. So now we know our m value, okay? That's our m value. That is 3 over 4. We know our x value is a 6. We have our y value as a 4. And now we know our m value is a 3 over 4. We can put that into the equation of a straight line, which is y take away y1 is equal to m x take away x1, okay? And then if we do that, we get a y minus a 4, and that is equal to m, which is 3 over 4. And that would be x minus 6. And we can leave our answer like that. It just says find the equation of tangent to the curve at P. We have found the equation. We don't need to simplify it down or anything. We can leave it like that. Now for part B, we need to find the equation of the curve, okay? So now to find the equation of the curve, we're going to need to integrate, okay? And when we integrate, we're going to get a constant. We're going to get a c, right? And once we get our c value, then we can put in our coordinates at P, so 6 and 4, help us work out our c value, and then that will be the equation of the curve. So first thing first, let's integrate this, okay? So think about integrating this, then what would happen, okay? What would come out of this? So with the half x, right? Now, with the half x, if we're differentiating, we'll take that factor of a half out, right? When we are integrating, we just need to take that factor out and do the reciprocal. So instead of taking a half out, we now are going to be, or instead of multiplying by a half, we're now going to be multiplying by a 2, okay? So if we want to integrate this, we start off with a y. Then we would need to multiply by 2, okay? Because we have the fact, we take a factor of a half out, do the reciprocal. So now we do 12 times 2, so that will be a 24. In brackets, we still have the half, x minus 1, and then we need to add plus 1 to the power, so we get a minus 3, and then divide by that new power, so we get a minus 3. And don't forget to have your plus c as well. And if we simplify this down a bit, we get y is equal to a minus 8, in brackets, a half x minus 1 to the power of minus 3, and that is plus our c value, okay? And now that we've got this, now we can put in our coordinates of p, so that was 6 and 4. And now we can use this to work out our c value, okay? So if we do that, therefore we would get a 4 is equal to a minus 8. Now half times a 6 is a 3, and then a minus of 1 is a 2. So it's 2 to the power of minus 3 plus c, which is 4 is equal to minus 8. 2 to the power of minus 3 is 1 over 8. So we're timesing by 1 over 8 plus c. And then that gives me a 4. Minus 8 times 1 over 8 is a minus 1 plus c. Therefore, c is 5. And now that we've got c is 5, we've worked out our c value. Now we know everything, and therefore it would be y is equal to a minus 8. And then in brackets, we have a half x minus 1 to the power of minus 3, and then plus our c value now, which was 5. Okay, question 3. So we've got this curve of equation y equals ax to the power of a half minus 2x, where x is greater than 0 and a is a constant. The curve has a stationary point at the point P, which has x coordinate 9. We need to find the y coordinate of P, okay? So effectively, all we need to do is if we differentiate y, okay, we get dy over dx. If we equal that to 0 and put in our x value of 9, then that should help us work out what our a value is. Then once we know what a value is, then that can also help us work out what the y coordinate of P is as well. So first thing first, let's differentiate this. So we start off with y is equal to ax to the power of a half minus 2x. If we differentiate that, okay, we get a dy over dx. Now, what would that be if we differentiate this? Well, we would get a half ax to the power of a half, okay? And then we get a minus 2, okay? Now, we know that's a stationary point, so we can make dy over dx equal to 0. So therefore, we're left with 0 is equal to a half ax to the power of minus a half minus 2. Okay, and then we can bring that 2 to the other side, so we get a half ax to the power of a minus a half. Now, don't forget, we also know what our x value is. So if I just, let me still go down. So let me multiply both sides by 2 to get rid of the half. So we get a 4 is equal to ax, the minus a half. And we know that x is 9. So now let's put in our value for x now, which is 9. So 4 is equal to a times by 9 to the power of minus a half, okay? So that'll be 4 is equal to a, and then that's effectively, we need to do the reciprocal of 9, so we get 1 over 9, and then do the square root of 1 over 9, which is 1 over 3. So we know that that will be 1 over 3, therefore, to work out a, now we just need to times by 3 on both sides, so 4 times 3 is 12, therefore we know that a is equal to 12, okay? And if we know that a is equal to 12, well, if we go back to the original equation, okay, so we had y is equal to ax to the half minus 2x. Well, now if we know that a is equal to 12, that now becomes that y is equal to a 12x to the half minus a 2x, okay? And if we find the y coordinate of P when the x coordinate is 9, well, then now we can do that because we can just substitute in 9 again to the equation of y. So now we get 12 times 9 to the power of a half minus 2 times 9, which gives me y is equal to a 12. Square root of 9 is 3, so 12 times 3 minus 2 times 9, which is 18, which gives me 36 minus 18. Therefore, we know that y is 18, so the y coordinate of P is 18. Okay, question 4. We have that the coefficient of x squared in the expansion of 1 plus 2 over px to the power of 5 plus 1 plus px all to the power of 6 is 70. Find the possible values of the constant p. Okay, this is a binomial expansion question. So what we need to do is just need to get our x squared coefficients for both of these expansions here, and then just equal that to 70, okay? And then we should get some form of a quadratic equation. So if I do that, what would we get? So let's start with the 1 plus 2 over px to 5. Well, if we think about the binomial expansion, but only when we wanted to know the x squared coefficient, okay, then that would be a 5, choose 2, okay? That'll be times by a 1 to the 3. We can just write 1, but I'll just write a 1 to the 3. And then that'll be times by 2 over px. Remember, all of that will be getting squared, okay? So this will give me an x squared coefficient. So that's that one. And now with the other brackets, okay, we do the same thing. This one will be a 6, choose 2, times 1 to the 4. And this one will be times by px, and that will all be squared. And that will also give me a x squared coefficient as well, okay? And we know that this must equal 70x squared, okay? So now if you work this out, well, we know that 5 choose 10, 5 choose 2 is 10. So 5 choose 2 is 10, obviously 1 to the power of 3 is just 1. And then that will be multiplied by a. So this way you have to be a bit careful. So we have a 2x, and then that's all going to be squared. So we get a, if in brackets, we get a 4x squared over a p squared, okay? And then for the next one, we have 6 choose 2. Well, 6 choose 2 is 15. So that'll be a 15. And then obviously 1 to the power of 4 is just 1. And then we would get a p squared x squared, okay? And that will equal our 70x squared. And then if we just work this out, we would get a 40x squared over a p squared minus a 15p squared x squared, and that is equal to a 70x squared, like that. And now we're at this stage. Well, now as you can see, we have x squared in all of them. So now, obviously, at this stage, we can just get rid of our x squared because we want to look at the value of p. So therefore, we are left with a 40 over p squared minus a 15p squared is equal to a 70. And if we, to get rid of the fraction, if we multiply everything by p squared, we end up with 40 plus a 15p to the power of 4 is equal to a 70p squared, and then we are getting what looks like a quadratic equation. So if we bring everything to the left side, we have 15p to the 4 minus 70p to the squared plus 40 is equal to 0. And lucky for us, everything divides through by 5, so we get a 3p to the 4 minus a 14p squared plus an 8, and that is equal to 0. And then if we just do a little substitution, let y equal a p squared. Well, then we end up with a 3y squared minus a 14y plus 8, and that is equal to 0. And now we have a quadratic equation, okay, which we can solve. Okay, so for this one here, if we were to do it, well, again, like question 1, we have a 3y here and a y here because it's just a 3y squared. That's the only way we can get it in brackets, okay? And we have an 8, okay? So think about the factors of 8, okay? We have a 1 and an 8, or 2 and a 4. Well, in this case, a 2 and a 4 definitely looks like it will definitely hit better. And now you sort of think about, is it going to be 2 negatives or 2 positives? Well, in this case, if we've got minus 14, we know that both those values have to be 2 negatives. So now we've got a 4 and a 2. We've got to think about the way which we can get that. Well, if you think about it, we'll get 14, okay? We can times by a 3, do 3 times by minus 4, which gives us a minus 12, and then we can do another minus 2 minus a 14. So that tells us that it's going to be a y minus 4 here, and a 3y minus 2 here, and that is equal to 0, okay? And then once you get that, well, therefore we get a y is equal to a 2 over 3, and we also get a y is equal to a 4. But we're not done yet because obviously we used substitution, so we have to put back in our original value. So remember, working out what p was, we said that y was equal to p squared. So now that means that p squared is equal to a 2 over 3, and p squared is also equal to a 4. Therefore, p, if we square root both sides, we get a plus or minus a root 2 over 3. And then again, if we do it with a 4, we get a p is equal to a plus or minus the square root of 4, which is 2. Okay, question 5. We have this sector here, OAB, of a circle with center O. The length of the arc AB is 8 centimeters. It's given that the perimeter of the sector is 20 centimeters. Find the perimeter of the shaded segment, okay? So all we need to do is find the perimeter of this bit here. So we already know that the length of the arc is 8 as they give that to us. So all we need to do is work out the line AB here, and then we just need to add that with 8, and that will give us the perimeter. So how can we work that out? Well, what are we told? Well, we're told that the perimeter of the whole sector, OAB, so we're told that the perimeter of, let me do it from O and then AB, so all of this, we're told that that perimeter is 20. Now remember that it has center O, okay? And A and B, they are points on that sector, right? So therefore, if we know that all of this has perimeter 20, okay, we know that AO is going to be the same length as BO, okay? Because if it's a circle, A and B are just points on that circle with center O. So A and B must be the same distance, right? Therefore, we actually know what that is already. Because if we know the whole perimeter is 20, well, 20 minus 8 20 minus 8 is just 12, okay? So we know that A and B, well, 12 over 2, they have to be the same. So they each have to be 6, okay? So we know that the AO, the distance is 6, and we know that BO, the distance is also 6. So now we've worked that out, well, it becomes easy to work out what line AB is now, because now we can formulate some equations and we can figure out how we can work out what the line AB is. So what else can we do? Well, we've worked out that AO and BO are 6, okay? Well, what else can we know? Well, we can work out the angle as well. We can work out this angle here. We can work that out because if we know what the AO and BO are, well, they're just a radius, effectively. So we know that we have the length is equal to r theta, okay? And we know what the arc length is. They tell us that the arc length is 8. And now we know the radius is, we just worked that out, that is 6. And then we have theta here, so therefore theta is just going to be 8 divided by 6, which simplified down is 4 over 3. So therefore, we actually know what this angle is here. We know it's going to be 4 over 3. So therefore, if we know all of this, well, we have two sides and an included angle. We can use the cosine rule to now work out what that what line AB is using the cosine rule. So the cosine rule is a squared is equal to b squared plus c squared. Is the right one? B squared plus c squared. Yeah, minus 2bc cos a. Here we go. Yeah, so now that we know this, we can just use what we've got now, because we have two sides and the included angle. We can work out what that is. So for us, that'll be an a squared, okay? So that'll be a squared is equal to b squared plus c squared. So just the two sides, that'll be a 6 squared plus a 6 squared minus a 2 times a 6 times a 6. And then that's times by a cos of the angle, which is 4 over 3. We're in radians, so make sure you're in radians. And yeah, if you was to work all that out, okay, put it into calculator, you would get 55.1, okay, to one decimal place. And then if you square root that, you get A as a 7.42. So now we know A is 7.42. We know that this line AB is 7.42. Therefore, the perimeter would just simply be an 8 plus the 7.42, which gives me a 15.42. And to three significant figures, we'll just write that as 15.4, okay, to 3SF. And that would be it. Part B, we need to find the area now of the shaded segment, okay? So now we need to find the area of the shaded segment, okay? So if I just put my finger back here, well, the area of the shaded segment is pretty simple. All we need to do is work out the area of the arc, okay? So work out the area of the arc here, or the sector OAB. And then also if we work out the area of the triangle, therefore, and then we can just take away area of arc, take away area of triangle. So it'll just be area of arc minus area of triangle, and that will give us the area of this shaded region. So let's look at the area of the arc first. So the area of the arc, well, that will just be, the formula is a half r squared theta. So for us, that'll be a half times a 6 squared times theta, which is 4/3. Okay, so if you work that out on your calculator, you don't need to, you can do it in your head as well, or just do workings, but you will get 24. Okay, so we know that the area of the arc is 24. And let's go over this side. Now let's look at the area of the triangle. So the area of a triangle is, the equation would be a half AB sine C. So for this one, it will just be a half times 6 times 6, and then times that included angle. So that'll be a sine of 4/3. Make sure you're in radians. Okay. And then if you work that out on your calculator, you will get a 17.49. Once we know that, therefore it's fairly simple. We've got the area of both now. So we've got the area of the arc, which was 24. We've got the area of the triangle, which was 17.49. Therefore, we just need to do a 24 minus a 17.49, and to one decimal place, you will get a 6.5. Well, no, to three single figures, you will get a 6.51. Okay. So, yeah, and that'll be answer 6.51. Okay, for this one, we need to show that this trig equation can be expressed in the form of a sine squared theta plus b sine theta plus c is equal to 0, where a, b, and c are constants to be found. Okay, so what I'm going to do now is I'm going to make this over one single fraction. Okay, so I'm going to cross multiply and get over one single fraction. So if we do that, we will get a 1 times a sine theta minus cos theta. So that's a sine theta, okay, minus cos theta, and that's a plus a 1 times a sine theta plus a cosine theta. So sine theta plus a cosine theta, and that is all over a sine theta plus cos theta, and in brackets, and then another bracket sine theta minus cos theta, and that is equal to 1. Okay, so now we've done that. Now if we just let's just expand everything. So let's move the denominator to the other side, so just times it. So we just times it by the 1. So if we do that, we get a sine theta minus cos theta plus a sine theta plus a cos theta, okay? And then that is equal to a sine theta plus cos theta, and then a sine theta minus a cos theta. Okay, and then let's simplify this down. So we get a sine theta plus sine theta, so that is a 2 sine theta, and the minus cos theta plus cos theta cancels out, so that just becomes 0. Then on the other side, we get a, this is a difference of 2 squares, so we get a sine squared theta minus a cos squared theta. Okay. So now we've got this, and now the question, as you can see, we want to express it in the form where we just have sine thetas. So right now we've got 2 sine theta, we've got sine squared theta, but then we've got this cos squared theta. So to get rid of that, well, we can use the trig identity, because we know that sine squared theta plus cos squared theta is equal to 1. Then we can just rearrange that to get an expression for cos squared theta, and yeah, therefore we can eliminate the cos squared theta and turn it into sine theta. So in this case, okay, what would that be? Well, therefore that would just be a cos squared theta is equal to a 1 minus a sine squared theta, and then we just substitute that in. So in R1, we'll get a 2 sine theta is equal to a sine squared theta minus a 1 minus a sine squared theta. Okay, so we get 2 sine theta, and that is equal to a sine squared theta minus a 1 plus a sine squared theta. Watch out for your, make sure your signs are the right way around. And now we get this, we end up with a 2 sine theta is equal to a sine squared theta. Actually, let me put that as 2 sine squared theta minus a 1. And if we bring everything to the right side, we get a 2 sine squared theta minus a 2 sine theta minus a 1, and that is equal to 0. And yeah, that would be our answer, okay? 2 sine squared theta minus 2 sine theta minus 1 is equal to 0. And now we've got to solve this equation now, where theta is between 0 and 360, okay? So again, if I just rewrite it, we had 2 sine squared theta minus 2 sine theta minus 1 is equal to 0. Let me use substitution. So let's let y equal sine theta. And by doing that, we can get this into a nice looking quadratic equation. So we get a 2y squared minus a 2y minus a 1, and that is equal to 0. Now for this one, it will not, we can't be put in brackets. It's a bit more challenging, so we have to either use the quadratic formula or completing the square to get our values, okay? So for this one here, I'm going to complete the square. If I complete the square, we get a 2 in brackets, we get a y squared, okay, we get a minus a y and then minus a half, okay, and that is equal to 0. And then if I complete the square, we would get a y minus a half, that'd all be squared, minus a quarter minus a half, and that is equal to 0. And then that will give me a 2, then in brackets a y minus a half squared. And then for this one here, minus a quarter minus a half is minus 3/4, okay, and that is equal to 0. And then for this stage here, we can now get rid of this now. So we can now multiply everything by 2. So we get a 2, then in brackets a y minus a half squared. 2 times minus 3/4 is going to give us a minus 6/4. So a minus 3/2, and that is equal to 0. Therefore, we get a 2 times a y minus a half squared is equal to a 3/2, okay? And then if we just divide both sides by 2, okay, or effectively a timesing by 1/2, we get a y minus a half squared is equal to 3/2 times by a half, which is a 3/4, okay? And now we can square root both sides, so we get y minus a half is equal to this plus or minus the square root of a 3/4, which is actually just plus or minus the square root of root 3/2. So we get y minus a half is equal to plus or minus root 3/2, and therefore we have y is equal to a half plus or minus root 3/2. So now that we've got root 3, now we've got y is equal to a half plus or minus root 3/2. Therefore, go back to our substitution. Obviously, we said that y was sine theta. So therefore, we need to change this to sine theta is equal to a half plus or minus root 3/2. So now we know that our 2 points is sine theta is equal to a half plus root 3/2 and a half minus root 3/2. But first things first, what I would do is just double check that these are valid solutions, okay? Because we know that sine theta has to be a value between -1 and 1. So what I'll do is on my calculator, I would just work out a half plus root 3/2 first. So if I do that on my calculator now, a half plus root 3/2, what value do we get? Well, we get a 1.4, okay? So when I do a half plus root 3/2, I get to one decimal place 1.4. Now that is above 1, so we know that this is not going to be a valid solution for sine. Therefore, we can actually just disregard this. Okay, and now we'll do the same thing, but for half minus root 3/2, okay? So if we do a half minus a root 3/2, then what do I get? Well, for that one, I get a minus 0.4 to one decimal place. And that is in our region, okay? Because minus 0.4 is between -1 and 1. So we know that that will be a valid solution. So we know that in this case, our only valid solution for sine in this case would be a half minus root 3/2. And we know that that would also give us a negative value for sine. Therefore, we know that if I draw my cast diagram, okay, let's draw a cast diagram down here. So let's use this thickness here. If I draw my cast diagram here, then and I do my quadrants, so my quadrants would be A, S, T, C. Then we know that we're only going to be dealing in these quadrants here because that is when sine is going to be negative. So just be in these two quadrants here. Okay. So now your calculators, just make sure your calculator is in degrees, and then just do the inverse of sine, okay, to the half minus the root 3 over 2, your calculator, and you will get a minus 21.5 to one decimal place. Now, where would that minus 21.5 be? Well, that minus 21.5, if you think about it, that would be in this quadrant here, okay? So therefore, what does that actually tell us? Well, that tells us that actually it's going to be 21.5 degrees here. And we know that we're also going to be in that t quadrant too because sine is negative. So we're also going to have another 21.5 degrees here. So now we've worked that out. Well, now it's simple to work out what this will be when it's between 0 and 360, okay? Because now we're just going to effectively go in this direction. So this will be 1 point here. And then this will be our other point here between 0 and 360. Therefore, theta would be 180 plus 21.5, which is 201.5 degrees. And then it'll also be 360 minus 21.5, which will give us a 388.5 degrees. Therefore, our two values would be 201.5 and a 338.5 degrees. So for this question now, we've got a tool for putting fence posts into the ground. It's called a post rammer. Distances are in millimeters. That the post sinks into the ground on each impact of the post rammer. They follow a geometric progression. The first three impacts cause the post to sink into the ground by 50, 40, and 32 respectively. Verify that the ninth impact is the first in which the post sinks less than 10 millimeters into the ground. So effectively, what we should do in this question is if you want to verify the ninth impact is the first one to be less than 10, then we should work out the eighth impact, and that eighth impact should be greater than 10, and then work out our ninth impact, and that one should be less than 10. Therefore, that would be the first impact, which is less than 10. Okay. So what I'm going to do is I'm going to work out the eighth impact. But first and first, let's put this into a geometric progression. Okay. So what do we know? We know the first impact is 50. We know the second impact is 40. And we know the third impact is 32. And they said that this models a geometric progression. So there should be a common ratio, okay, a common multiplying factor. In this case, that would be 4 over 5, okay, or 0.8. So we know that this would be a times by 4 over 5, and then this will also be times by 4 over 5, okay? So therefore, that is what we're doing. Therefore, we know that our R value is 4 over 5. Okay, we know our A1, our first term, is a 50. And what is the equation of a geometric progression? Well, the general equation to look at any term is AN is equal to A1 times by R to the power of N minus 1. Okay? So if we look at the eighth term, then that'll just be an A8 is equal to A1 times by R to the power of 7. Okay? So let's work that out. So A8 would be A1, which we know is 50. And that'll be times by R, which we know is 4 over 5, to the power of 7. Okay? And if you work that out, you get to loads of decimal places, you get a 10.48576. Okay? So that's good. We know the eighth term is still above 10, which is what we want to see. Let's look at our A9th term now, our ninth term. So that'll be A9 is equal to an A1 times by R to the 8. So A to the 9 would be a 50 times by 4 over 5 to the power of 8. And if you work that value out, in your calculator, you get an 8.39, which is perfect. 8.39 is less than 10. And we worked out that A8 was still above 10. Therefore, yeah, hence ninth impact. And And you can always even write and the first impact to be less than 10. Okay, something like that. And yeah, nice, easy marks. So next question, we need to find to the nearest millimeter the total depth of the post in the ground after 20 impacts, okay? So they pretty much want us to work out the sum of the first 20 impacts, okay? You got to be careful of this because you may think, oh, it's a convergent geometric sequence. I can just use the sum to infinity. That'll give me the answer. You'll be very careful because it says find the nearest millimeter the total depth of the post in the ground after 20 impacts, okay? That's the key. It wants it after 20 impacts. It doesn't just want the sum. It wants it after 20. So therefore, we need to work out s to the 20. Now, even though this is going to be a convergent, it may not be convergent after 20 impacts. It most likely won't be. So we need to use it's a general formula for the sum of a geometric sequence. The one which we usually use when something is divergent, we're going to still use it here. So if we think about the general formula for a geometric sequence, okay, then that will be Sn is equal to A1, and then in brackets we get a 1 minus r to the n, and that will be all divided by 1 minus r. And for us, we're going to do that when S is equal to 20, okay? So again, we still have our A1 as 50, we still have our R as 405, and in this case, our N value will be 20. And then we just do it as normal. So for us, that will be A1, so that is a 50, 1 minus a 4/5 to the 20, okay? And then that is over a 1 minus a 4/5. And if you work out that value on your calculator, okay, to the nearest millimeter, you will get 247, okay? So the answer will just be 247. And then for part C, now it says find the greatest total depth in the ground which could theoretically be achieved. So now with this one, now you would do the sum to infinity, okay? This one would be the sum to infinity. And this one, the equation for that would just be A1 over A1 minus R. So therefore, that is just A1, which again we know is 50, over a 1 minus 4/5, okay? And if you to work that out, you get a 50, and that'll be over a 1/5, which would then be a 50 times a 5. So that one would just give us a 250, and then yeah, we can write millimeters here. So yeah, that would be it. So we know that theoretically 250 is the greatest depth we can achieve, okay? And yeah, that'll be answer 250. So for this question, okay, we have a function f is defined by f of x is equal to 2 minus 3 over 4x minus p for when x is greater than p over 4, where p is a constant. Find f dash x and determine whether f is an increasing, decreasing, or neither. Okay, so all we need to do is pretty much work out f dash x, okay? Then once we got f dash x, we need to just determine whether it's going to be increasing or decreasing, okay? So is it going to be greater than 0? Will it be less than 0 for all the values of x and things like that? So let's look at what f dash x is first, okay? So first thing first, I'm going to rewrite this. F of x, I'm going to rewrite it as 2 minus a 3, and then I'm going to write 4x minus p to the minus 1. And that'll just make it a bit easier for me when I want to differentiate. So we get an f dash x, that 2 will just cancel, goes, and then we're left with a 3. Now a 4 would come out of the bracket, so we get a minus 3 times a 4, but then also with times by minus 1 as well. So we end up with a positive 12. And then in brackets, we get a 4x minus p, and then we minus 1, so we get a minus 2, okay? So now we know that f dash x is 12 times by 4x minus p, and that's all to the minus 2. And now we want to now determine what will this be, okay? Will this be greater than 0, less than 0, or neither, okay? So that's what we want to determine now. So if I just rewrite this, so therefore, if I change this, we get a 12 over a 4x minus p all squared. And now if we look at this, well, we know that x, they tell us in the question, x is going to be a value greater than p over 4, okay? So they tell us that. So what does that mean? That means that when x is a value greater than p over 4, it would then, when we square all that numbers, right, we're just going to get a squared number greater than 0. That effectively tells us that because of that, we know that 4x minus p all squared is going to be a value greater than 0, okay? And if that's going to be a value greater than 0, then 12 divided by a positive value, okay, would just give me a positive value all the time. So therefore, we know that this has to be greater than 0, okay? Because we know that for when x is greater than p over 4, 4x minus p squared will always would give us a positive value, because you're going to square the value anyway, and you won't get 0 because you can't get 0 because of the whole p over 4 thing. So you won't really be able to get you won't be able to get 0, so it'll just be a value greater than 0, right? Because you're squaring it. Therefore, by doing that, 12, which is a positive value, divided by a value which will always be a positive value, is always going to give me a positive value. Therefore, we know that 12 over 4x minus p squared will always be greater than 0. And if that's always going to be greater than 0 for all those values of x, which is greater than p over 4, therefore, we know that this is going to be an increasing function, okay? So just, you got to think about the properties of a square number in that one. Think about the properties and think about like what type of values you're going to get. It's always going to be greater than 0. You can even put in random values you want for x and p's. It doesn't really matter, okay? Because at the end of the day, as long as it's not 0, which we've accounted for, which so it can never be 0, you'll always get just a positive value, because when you square, it doesn't matter what number you value you square, you're always going to retain a positive value, okay? So really that's it. Just learn the properties of square numbers and you should be fine. So now we need to express f to the minus 1x in the form of p over a minus b over cx minus d. Okay, so effectively, if I write f of x again, so f of x, what was f of x? So f of x was a 2 minus a 3 over a 4x minus p. We need to pretty much work out the inverse, okay? And then put it in that form which they want. So look at the inverse. What I'm going to do is I'll make all my x's y's and all my y's x's. So we end up with an x is equal to a 2 minus a 3 over a 4y minus p. And now I'm just going to rearrange this and get, rearrange it and let y be the sort of the formula, and that should give me the inverse. Okay, so now what I'm going to do is I'm going to bring that 2 to the side. So we get x minus 2 is equal to a minus 3 over a 4y minus p. And now I'm going to multiply both sides by 4y minus p to get rid of the fraction. So we get an x minus 2, and that's times by a 4y minus p, and that is equal to a minus 3, okay? And now if we multiply this out, we get a 4xy minus a px minus an 8y plus a 2p, and that is equal to a minus 3. Now I'm going to group up all of my y terms together, so we get a 4xy minus 8y, and then I'm going to bring all my other terms to the other side now, so we get a minus 3, and then we would get a plus a px, and then minus a 2p. And now what I'm going to do is now I'm going to factorize out the y on the left side. So we get a y, and then in brackets we get a 4x minus 8. And on the right side, I'm going to do a similar thing, but just with a p, okay? Just because in our question, as you can see, we have like a p over a. So I'm going to factorize out the p as well, just a px minus 2p. So we get a p, and then we get an x minus a 2, okay? And now we can divide both sides by the 4x minus 8 now. So now we get y by itself, and that is equal to a minus 3. And actually, let me do it as one single fraction first. So minus 3 plus p x minus 2, and that is over a 4x minus 8. And now what I'm going to do is I'm going to split these fractions up into 2. So we get y is equal to a minus 3 4x minus 8, and then for this one we get a p x minus 2. Now we could write 4x minus 8, but actually we can actually factorize that too, because that will be a 4x minus 2. And now, because of that, we can just cancel out the x minus 2. Therefore, we're left with y is equal to a minus 3 over a 4x minus 8, okay, plus a p over 4. And if we want to write that in the exact form they have, then we just need to move it around. So that'll be a y is equal to a p over 4 minus a 3 over a 4x minus 8. And for part C, we need to state the value of p for which f of the minus 1x is equal to f of x. So for us, that will be the p minus 4, okay? That'll be minus the 3 over a 4x minus 8, and that will equal the 2 minus the 3 over a 4x minus p. Effectively, we can just compare the coefficients and work out what our p value is. Because if you just look at this, both are in the exact same form here. So effectively, we can just take the p over 4, and that p over 4 has to equal 2. Because we just compare all the coefficient stuff. That's the only way we can get a value for p, is if p over 4 is equal to 2, something like that. Yeah, and then just by looking at that, well, we know what it is now. And therefore, we just need to do 4 times 2. So yeah, we know that p is just equal to 8. Okay, for question 9, we have functions f and g are both defined for when x is all real numbers and are given by these two equations here. First, we need to express f of x in the form of a minus a squared plus b. So effectively just completing the square. So if we do that, we get an x minus 2 squared minus 4 plus 9. And then that simplifies down to x minus 2 squared plus 5, and we are done. Second question, we need to express g of x in the form of 2x plus c squared plus d. So again, completing the square again. For this one, if I just rewrite g of x was a 2x squared plus 4x minus 12. So we just want to complete the square on this. Therefore, it would be take a factor of 2 out, so we get an x squared plus 2x plus 6, okay? Now if we complete the square, we get a x plus 1, that would be squared, minus a 1 plus a 6, and therefore our answer would just be 2, and then in brackets we would get an x plus 1 squared plus 5, and that would be our answer for B. Now for part C, we need to express g of x in the form of kf of x plus h, okay? So effectively what they're saying is, how can we express that, okay? Well, what they're effectively saying is, if we have f of x, okay, at the moment we have f of x as x minus 2 squared plus 5, okay? And we also have g of x at the moment as 2, and then in brackets x plus 1 squared plus 5, okay? Effectively, if we want to express it in the form of k f of x plus h, then what you want to think about is, how are we going from f of x to g of x? Like, what is the transformation happening on the f of x to get it to g of x? Well, if you look, there are two parts, okay? As you can see, there are two distinct changes, okay? Now, one of them is you are multiplying by a scale factor of 2, okay, in the y direction, because we have this 2 on the outside. So, okay, we know that we're going to have a 2, okay? Let me write this in red. But another one is, if you look, we went from x minus 2 to x plus 1. So what's happened there? Well, that must mean that we've shifted 3 units, okay? In this case, we've shifted 3 units to the left. But if you want to think about this as a translation, or however you want to think about it, we've just effectively, how have we gone from the f of x to the g of x? It's effectively, in this case, it'll be x plus 3, okay? Because x plus 3 signals that we've shifted to the left, okay? So therefore, we know that it will just be 2 of f and then x plus 3. So that is effectively how we've gone from f of x to g of x in terms of just the f of x. Like, the f of x is just really being multiplied, well, stretched by a scale factor of 2 in the y direction, and then it's also been shifted to the left by 3 units, and we can write it like f of x plus 3. So we're done. That will just be 2f of x plus 3. And then for D, What we need to do now is describe the two transformations that have been combined for the graph of f of y equals f of x to the graph of y equals g of x. Now, this question is a bit weird because it's 4 marks, but as you can say, if you've done part C and you understand what you've done in part C, D is kind of an easy 4 marks. So effectively, for the first transformation, we can talk about the let's talk about the translation first. So we know that it's a translation. So this is when it's being shifted to the left of 3 units. We can just say a translation of minus 3, 0. That's all we need to do for the translation. We don't even need to say left, right, up, down. We can say a translation of minus 3, 0, okay? And what that says is that we've just shifted 3 units to the left, okay? So that's the first transformation. The second one is we can just say stretched by a scale factor of 2 in the y direction. Okay, and all I've done is I've just effectively just looked at this. I've effectively just looked at our answer for part C, and I've just said what those two are. Stretched by a scale factor of 2 in the y direction, and a translation of minus 3, 0. That is it. And we're done. For 4 marks, that's all you need to do for the 4 marks. It's a very nice question. Okay, question 10, okay? We've got these two curves, y equals 2x to the half plus 1, and y equals a half x squared minus x plus 1. It says they intersect at A, which is 0, 1, and B, which is 4, 5. Find the area of the region between the two curves. Okay, so fairly simple. We need to find this area here. Okay, and at first glance, this may be a bit difficult. You may be wondering, how do we do that? Well, effectively, if we just we think about this top line here, so this 2x to the half plus 1. Now it's intersects 0, so think about it. If it intersects 0 and then it has 4, right? So if I just draw the line here, well then for that top one, it would just be, all of this would be the area under the curve, right? This would be the area under the curve. So if we use integration, it would give us all of this, right? Now for that bottom graph, okay, if we do the same thing, well the bottom graph, if we do it again, that will also be between 0 and 4, but that will just give us this values here, okay, because that will be the area under that curve. So then as you can see, it's going to be the area of the top curve minus the area of the bottom curve, okay, and that will give us the area of the section we want. So again, in this form, we'll do the integration of the top curve minus integration of the bottom curve. Our limits will be between 0 here and 4 here, because that's what our a and b values are, the x coordinates for them, and that's all we need to do. So if I just draw that here, that would be a interval of a 4, 0, okay, 4, 0 of 2x to the half plus 1, okay, and that will be with respect to x, minus the interval of 4 to the 0 of the bottom curve, which was a half x squared minus x plus 1, and that is all with respect to x. And that's all we need to do. We need to work out this, integrate, put our limits in for both, and that should give us our area. So let's do that. So if we start integrating this, then what do we get? We would get a 2x, and then we're going to plus 1 to that, so we get a 3 over 2, minus a 3 over 2, and then we get a plus x, okay? And then that's all been our limits of 4 and 0, and that is minus, and then we do the same thing here. So for this one, we would get a half, and then we would get an x to the 3, and that would be divided by 3. Then we get a minus x squared over 2, minus an x, okay? And that would be all between 4 and 0. And if we simplify this down a bit, so we would get a 4 over 3x to the power of 3 over 2, okay, and that'll be plus x. And then we have 4 and 0 minus, this one would be a half divided by 3, so that's a 1 over 6 x to the 3. And then we still have the minus x squared over 2 plus x. and that is equal to, well, that has limits of 4 and 0. And now we can start putting in our values, okay? So let's put in our values of 4. So if we start on this left side here, so we get 4 over 3 times by 4 to the power of 3 over 2. So 4 to the power of 3 over 2, that would be the square root of 4, and then that would be 2 to the power of 3 is 8. So we know that will be a 4 over 3 times 8. So that would be a 20, oh no, 4 over 3 times 8, that would be a 32 over 3. And then that's just plus a 4. And then if we were to do 0, well, we would just get 0, okay? Because 0 would just, all of them would just be 0. So that's the first bracket's done. And that's minus the second bracket. So if we do the same thing for this one now, we get a 4 cubed. Okay, so what is a 4 cubed? A 4 cubed is 64. So 64 over 6, that would be a 32 over 3. And then we get minus a 4 squared, so 16 divided by 2 is an 8. Minus an 8, and then we get a plus 4. And then again, if we were to multiply everything by 0, we would just get a 0. So then the zeros, there's no 0. So therefore, we just have a 32 plus 4, which if we do a 32 plus 4, that's 32 over 3 plus 12 over 3. So that'll give me a 44 over 3. And then we have a 32 over 3 minus an 8 plus a 4. Okay. So if I was to work that out and put this into a calculator, you will get a 20 over 3. So there we just have 44 over 3 minus 20 over 3. That would give us a 24 over 3, which therefore gives us an area of 8. Part B, we've got this acute angle between the two tangents at P is denoted by alpha degrees, and the scales on the axes are the same. We need to find alpha. So this may be the first time you've seen a question like this, okay? And at first, it does look very challenging. But what we got to think of here is they've drawn on these extra lines here, and they've drawn them on for a reason, okay? As you can see, it's hard to see, but like they've drawn on these extra lines like here, and they've got an extra line here, an extra line here, extra line here, okay? Sorry for that motorbike. So why have they drawn that on? Well, actually, what we can do is, why they've drawn that on is because we can actually work out this line here. We can work out the length of this line here and the length of this line here, okay? And then that will give us a triangle, because if I use an actual colored pen now, change the thickness, well, if we can work out this line here, okay? And we can also work out this line here, okay? And why that's pretty cool, because if we work out what those lines are, as you can see, they're going to intersect. They intersect at the x-intercept there. There's going to be a y-intercept there. And then if I join these lines up, okay, like this, it's a bad one, and we join up again. If we join them up like this, okay, as you can see, now we're going to have some type of triangle, okay? And we can work out the distance of all those triangles because we have coordinates for all the points, okay? We will have coordinates because we already have the coordinates here for 4, 5. We can work out the equation of this line, therefore working out the coordinate when it crosses the x-axis down here. And we can also do the same thing. We can work out the lengths, because we can work out the equation of the line and work out the coordinates where it crosses the y-axis here. And by doing that, we can end up working out lengths for this, this, and this. And then we need to work out this angle here, because this angle would be the same as this angle, okay? They're alternate angles. So therefore, if we work out what this angle is, it should be the same as this angle here. Therefore, that will give us our answer. So all we need to do is work out the equation of these lengths, and then we can use the cosine rule to end up working out this one here. Okay? And that is what we're going to do. So now we can actually work out the gradients are at these points, because we know that they're going to cross at 4, 5, right? So therefore, if we have y, let's start with the 2x to the half plus 1. If we differentiate that, we just left with an x to the minus a half, okay? And now if we put in our value of 4, because that will tell us a gradient at that point, well, that will be a 4 to the minus a half, which is a half, okay? So what do we know? We know that the gradient here, this gradient is a half. We know that gradient is a half, okay? So we know that gradient is a half, and we have the points of 4, 5. Well, we can work this out because we can work out the equation of that straight line because we have x is 4, we have y is 5, and now we know that m is a half. So if we put that into the equation of a straight line, okay, we get y minus 5 is equal to a half x minus 4. So that's a y minus 5 is equal to a half x minus 2. And therefore, we get y is equal to a half x plus 3, okay? So we know that this line here, is going to be a half x plus 3. Okay, so we know that's a half x plus 3. So then, therefore, if I was just to draw my lines on again, let me use this one. So let me just go straight through it, actually, make it easier for myself. So if we think about that, if we draw this line on again, we know that this line here, this is a half x plus 3. So we know this is a half x plus 3, okay? Well, therefore, if we think about the y-intercept, well, the y-intercept, this point here, this must be a 0, 3. It's the y-intercept, okay? And now we're going to do a similar thing, but we're going to do it now for this value here. So again, we're going to differentiate. I'll do it on this side. So we know that y is equal to a half x squared minus x plus 1. If we differentiate this, what do we get? Well, we would get a... So I'll just give me an x, okay? And then just a minus 1. And then again, we do the same thing. So our m value, that would just be a 4 minus a 1. So that'll just be a 3. So we know that this gradient here is just a positive 3. And therefore, we can just do the same thing. Okay, we do the equation of a straight line. So if we do the equation of a straight line, okay, well, therefore, we get a y. Well, actually, let me put my values in first. So again, if I just scroll up, we have a x is equal to a 4, we get a y is a 5, and we get an m is a 3. So put that into the equation of a straight line. We get a y minus a 5 is equal to a 3, x minus a 4, which therefore means we get a y minus a 5 is equal to a 3x minus a 12, okay? So therefore we end up with y is equal to a 3x minus a 7, okay? So what does that tell us? Well, we know that this point here, we know this line here has to be y is equal to 3x minus 7. So if I draw this on now, so if I use this, then we know this here must be the line of 3x, y is equal to 3x minus 7. Therefore, all we need to do now is work out the x-intercept, okay? So if I just do the x-intercept over here, if we work out the x-intercept, well, of y is equal to 3x minus 7, then just need to make y 0, okay? So you make y 0, you get 3x minus 7, and if you rearrange that, you will get x is equal to 7 over 3. So what does that tell us? That tells us that this point here is 7 over 3, 0, okay? So it's a bit long-winded what I've done, but effectively, okay, this is what all you need to do now is now work like that. Now we've worked out all our points. We have 3 points, right? And now we can make this into the form of a triangle, and that can help us work out our angle. So if I go over to this page now, and let me just draw in my triangle. Okay, so as you can see, I've just drawn my diagram here now. So I've got all my coordinates now. As you can see, it just makes a triangle, okay? And we can just look at the lengths of these triangles, and that will help us work out what that angle is. So effectively, if I just label this now, my labels are going to be different than what we're given. I'm just going to call this A, I'll call this B, and I'll call this C for now. And now, bear in mind, these letters are not always going to be the same as what we're giving in the question. These are just the ones I'm going to use. But yeah, so now that we've done that, now let's work out what alpha is, okay? So first thing first, let's look at what our lengths are. So let's look at what I've done as my A and B line, okay? Let's look at what that length would be. So we would get a 5 minus 3, okay? That'll be all squared, okay? And then we'd also get I guess just a 4 minus 0, so a 4 squared. So we get this, and if you work that out, that would be just a 2 squared plus a 4 squared, so we get a root 20, okay? So we know that this this length here is root 20, okay? And we just do the same for all of them, okay? So let's do A and C now. So if you do A and C, okay, you get a 4 minus a 7 over 3 squared, okay? And then you'd get just a 5 squared. So that would just be, and that's all squared, so you get a 5 over 3 squared plus a 5 squared. That'll be all squared, okay? And if you do that, you get a 5 root 10 over 3. So you know this length is a 5 root 10 over 3. And then just do the same thing for that B and C line I've got now. So if doing for that one, again, you would get this one would be a nice one in the sense it would just be a 7 over 3 squared. And then we just get a plus 3 squared. And then if you work all of that out, you get the square root of 130 over 3. So we know that this line is square root of 130 over 3. We worked out all the lengths now. And now we can use cosine rule to work this out. So for cosine rule, that would, in this case, that would be like a cos A is equal to a B squared plus C squared minus A squared over a 2bc. So therefore, for us, that would be a cos A or alpha. In this case, let's call it alpha. That would equal a B squared plus C squared, which in our case, that would be a root 20 squared plus a 5 root 10 over 3 squared minus the square root of 130 over 3 squared, okay? And that would be over 2 times a root 20 times a 5 root 10 over 3. Okay, and if you put all that into a calculator, you would actually get a cos alpha, and that would equal a 0.707, and we'll just keep going like that, okay? And if you just do the inverse of cos of that value, keep it into your calculator, you will get exactly the value of 45. So it actually turns out pretty nice. But doing this question, yeah, it's pretty long. I mean, this way I've done it. There are other ways you can do it too. I think this way is the best way to explain it for you to do it. If you know that you can just work out your equation of the lines and then just work out the lengths and then just use cosine rule, I think that's a nice way to do it. But there are other ways to do it as well. But yeah, if you do that, you will get your alpha value as 45. And because we get this value here as 45, then alternate angles here, this will also be 45 as well. Therefore, our alpha value is, yeah, just 45, okay? Okay, question 11, okay? We have this circle here and these tangents. So the circle has equation x squared plus y squared is equal to 20. And the tangents touching the circle at points B and C pass through the point of A, which is coordinates of 0 and 10. By letting the equation of the tangent be y is equal to mx plus 10, we need to find the two possible values of m. So they've actually given us the equation of the tangent, okay? So we know that it's mx plus 10, okay? And because they've given it to us, well, we can just substitute that in to the equation of the circle because they intersect, right? And that will give us some type of equation in terms of m. So let's just do that first, okay? So if we have that x squared plus y squared is equal to 20. We also have that y is equal to mx plus 10. We want to work out what m is, okay? Well, if they intersect, we know that two possible values of m is the gradient, okay, in this question. So if we look at this here, we know that what they're saying is m could be this gradient here, m could be this gradient here, okay? These are two independent lines. It can have this gradient or it can have this gradient here, okay? And we need to figure out what those points are. But we know they're going to intersect because they have to intersect, right? So therefore, if I do that, we get x squared plus, now change my y to mx plus 10, and that will all be squared, and that's equal to 20. Now, what is the whole point of this? Well, what we want to do is, as you can see, that each of these tangents, right, they're only going to hit the circle at one point. So therefore, remember, it's the discriminant. When we want to think about stuff like this, if something has one solution, right, it will just be b squared minus 4ac is equal to 0. When it has one intersection, that will be the discriminant. And once we work out the equation, well, we can just use b squared minus 4ac is equal to 0, and that will tell us the points of m, okay? So that's what we need to do. So I'm going to expand the brackets out now. So we get x squared is equal to m squared x squared. That will give me a 20mx. We get 10mx plus 10mx. And then we get plus 100, and that is equal to 20. So therefore, we get a x squared plus m squared x squared plus a 20mx plus an 80, and that is equal to 0. And now what I'm doing is I'm just take out all my factors of x squared, x, and just to make it look more like a quadratic equation. So in this case, we'd have a 1 plus m squared, and then I'll put my x squared on this side, so now it resembles a quadratic, plus a 20m, and then again, I'm going to put my x on the outside, okay, plus 80, and that is equal to 0. So now we've got it in this quadratic formula, and as I mentioned earlier, we know that because each of those independent lines, right, they intersect the circle once. Now remember, be careful. These are two independent lines. They do not intersect the circle twice. Each of these lines only intersects at one point. So therefore, we can use b squared minus 4ac is equal to 0. And because we have an m squared, that is how we're going to get our two possible values. So if we do b squared minus 4ac is equal to 0, okay, we know that our a value is a 1 plus m squared. We know our b value is a 20m, and we know our c value is 80. So therefore, it would be a 20m all squared, okay, and that will be a minus a 4 times an a, but I'm going to do 4 times a c first because it's a constant. So it'll be 4 times an 80, which is 320. Now I'm going to times by the a, which is 1 plus m squared, and we know that must be equal to 0. So 20m all squared is a 400m squared minus a 320 minus a 320m squared. That must equal 0. Therefore, we get an 80m squared minus 320 is equal to 0. So therefore, 80m squared is equal to 320. Therefore, m squared is equal to 4. Therefore, m is equal to a plus or minus 2, okay? So we've got m as plus or minus 2. So we worked out our two m values, plus or minus 2. And as you can see, if we were to look at this, therefore this one would just be the positive 2, and then this one would be the negative 2, okay? And those are our gradients, plus or minus 2. So now for part B, we need to find the coordinates of B and C. So we just look at this here, the coordinates for B and C, okay? So how can we work out the coordinates of B and C? Well, what we did here, remember when in the previous question, we worked out this over here, okay? And now because we know what our m values are, we can just plug in our m values. So we can plug in 2 and then also minus 2. It'll give us the quadratic equation, and then we should be able to simplify that down, and then get a value for x. We can just solve, get a value for x, and then in turn get a value for y as well. So that's what we're going to do. So again, if I just write that here, so it was a 1 plus m squared x squared, and that was a plus a 20mx, okay, and then plus an 80. If we just substitute in our values, so let's start with when m is 2, okay, so when m is 2, we get a 5x squared, okay, plus a 40x plus an 80, and that is equal to 0. And if we simplify this down, everything goes into 5, so x squared plus 8x plus a 16, okay, that's equal to 0. And as you can see, this is just going to be, because we know that it should only be one x value, we can tell that this is just going to be squared, okay, so we know that this is going to be x plus 4 squared is equal to 0. Therefore, we know that our x value is equal to minus 4. So now x value is equal to minus 4, okay? And now for the second bit, remember, if we want to work out the x, we could, one of the equations we could use a circle one, which is x squared plus y squared is equal to 20. That one's pretty difficult. But remember, we also had that y is equal to mx plus 10 as well. So we're going to use that one because we know what m is now. In this case, m would be just a positive 2, so it'll be y is equal to 2x plus 10. And we can use that to work out our our y value, okay? So by doing that, it'll just be y is equal to a 2 times a minus 4 plus a 10, which would be a minus 8 plus a 10, which is a 2. So we know that for the b value, okay, b would simply just be a minus 4, 2, okay? So that is our b coordinate, is minus 4, 2. Now we do need to do the same thing, but now for the c coordinates, that was when m was minus 2. So again, when m was minus 2, we would get a 5x squared still. This would change. Now this would be a minus 40x. We still get an 80 equal to 0. Again, we can simplify down again. So we get a minus 8x plus 16 is equal to 0. And this one would be an x minus 4 all squared, okay? That's equal to 0. Therefore, in this case, x would be a 4. So now for this one, we know that for the equation, we get a y is equal to mx plus 10. But for this one, it will just be, because m is minus 2, it'll be a minus 2x plus 10. Therefore, when we substitute in y equals to minus 2 times 4 plus 10, then that will give us a minus 8 plus 10. So therefore, minus 8 plus 10 is 2. Therefore, we get our c value, okay? Our c value as a 4 and a 2, okay? So we got our coordinates of b was minus 4, 2. Our coordinates of c was 4 and 2. And if you look at that, that does make a lot of sense, because if you look at this line here, I mean, it's in that quadrant, so you should get a negative x value, which we do, and a positive y value. And then for this c value, it's in this quadrant here, which you should get a positive x value and a positive y value. So yeah, minus 4, 2 and 4, 2. Yeah, and that's that question done. In our last question, we need to, we're told that the point D is where the circle crosses the positive y-axis. We need to find angle BDC in degrees, okay? So if I am back here now, so what we can do is, if we want to find angle BDC, okay, so if I just draw a line, so like this, and then like this, and all the way. This one should just be a straight line. Okay, that's as good as I can get it. Okay. So effectively, we've got this triangle here. And we need to work out this angle here. Okay, let's call this angle, oh no, let's call it alpha. So that's what we need to work out. And yeah, what do we know about this triangle? So we know that BC, as we worked on the previous question, we know this is minus 4, 2, and we know that this is 4, 2. So let me just make this look like it actually looks like a triangle here. So because we know that, we actually know the distance of BC is simply just going to be 8. Okay, we know the distance of BC is just 8 because it's 8 across. So minus 4 to 4, that's just 8 across. So we know the distance of BC is just 8. All we do now is work out the distance of BD and work out the distance of BC. Okay. So first things first, let's try and work out a coordinates for D, okay? Now we know D is when the circle crosses the y-axis. So again, if we know that the equation of the circle is x squared plus y squared is equal to 20, well, we know that if D is where the circle crosses the y-axis, then all we do is make y 0. So we get x squared is equal to 20. Therefore, x is just simply equal to root 20. So therefore, we actually know that this point here is going to be a root 20, 0. So now we've got all our coordinates. Again, it's about working out the distances of all of this. And then once you know the distance of everything, yeah, you can just use cosine rule and you can work it out. Okay, so let's work out BD first. So with BD, if we look at the distance of that, well, what would that be? Well, the distance of that would be A. So we have a root 20 and we have a minus 4. Now, root 20 is bigger than 4, okay? So we know that it would be a root 20 minus a minus 4 in this case, okay? So let's do a root 20 minus a minus 4. So that gives me a root 20 plus 4, okay? So it'll be all of this squared, and then we just get plus that'll be a distance of 2. So just be a distance of 2 squared, and then all of that will be squared, okay? And then, oh, and this should be a squared here, okay? And then actually, we can actually work this out and just simplify it down a bit just to make it easier for ourselves later. So if we do that now, what do we get? Well, we actually get a root 20 all squared is just going to be a 20. And then we would also get a root 20 times 4 plus another root 20 times 4. So we get a 8 root 20. And then we also get a plus 16 here as well, okay? And then don't forget the plus 4 because 2 squared. So this actually simplifies down to the square root of 40 plus 8 root 20. And yes, while we can simplify this down even more, we can just leave it like this for now, and that is fine. So what do we know? We know that the distance of BD is the square root of 40 plus 8 root 20. And this doesn't look nice, but don't worry because it will simplify down later. So now we do the same for CD. Now with CD, we have root 20 and 4, okay? So that would be the square root of root 20 minus 4. Okay, that'll be all squared. And then we also have 2 and 0 again, so that's a plus 2 squared. And we just can do the same thing, okay? So that'll be a 20, so we get a 20 here. Then we would get a minus 8 root 20. And then we would get a positive 16. And then a positive 4. And that simplifies down to the square root of a 40 minus 8 root 20. So now we know that DC, the length, is the square root of a 40 minus an 8 root 20, okay? So now we've got all of our lengths, okay? So now I'm going to draw it from the other side, and then we can work it out. So now I've drawn my triangle here, and now I'm just going to work out, use cosine rule now, because we have all the lengths. So I can use cosine rule to look at the angle. In this case, because we have BCD, I will write the cosine rule in terms of BCD. So we have the cos of D is equal to a B squared plus C squared minus D squared over 2BC. And then we just draw that on. So this would be like a D, this would be our B, and then this would be our C here. And so now if I work this out, actually, let me just work this out fully, actually, because we can actually work this out fully and simplify it down. So I'm going to do cos of D. Okay, now because we're just squaring, okay, the square root will cancel out. So we're actually just left with a 40 plus 8 root 20. And then we're left with another 40, this time minus 8 root 20, okay? And then that will just be minus D. Well, that'll just be minus D squared. Well, that is just a minus an 8 squared, okay? So like that. And then that will be over. That'll be over the 2 times the square root of 40 plus 8 root 20. And then that will also be times the square root of 40 minus 8 root 20. So let's start with the denominator, okay? Not the denominator. Let's start with the numerator. So that one would just simply be so we get a 40 plus a 40. So we'll get an 80. We also have a minus 8 squares. That's a minus 64. And then our 8 root 20 cancels out with a minus 8 root 20. So we're just left with 80 minus 64. That's numerator. And now let's do the bottom bit. So this is where it can get a bit more challenging, okay? So what I'm going to do is effectively I'm going to just do the square roots times by each other first, okay? So we'll leave the 2 outside the brackets. And then inside, well, when you have a square root like this, you can actually put everything over the square root. And then effectively, you just get where 40 plus 8 root 20, and that'll be all squared. And then a 40 minus 8 root 20, okay? And that will be all squared like this, and then it's all over the 80 minus 64. So then 80 minus 64 is 16, okay? And then we're left with a 2, and then inside those brackets, we can just think about it as times by the square root. Well, 40 times 40 is 1,600, okay? And then if we do the rest, we get a it'll cancel out, obviously, the difference of two squares. So we don't need to worry about the 40 times minus 8 root 20 and the 40 times 8. That'll just cancel out. So then we just can do 8 root 20 times by minus 8 root 20. So that'll give me a minus 64 because 8 times minus 8. And then root 20, that's just a 20. So times by 20. So now we get a 16 over a 2 times, if you do square root of 1600 minus 64 times 20, do the whole square root, you get an 8 root 5. So therefore we get a 16 over a 16 root 5, which is now just simply going to be a 1 over root 5, okay? So what does that mean? Well, remember that all of this was the cosine rule, so this is all going to be cos d, right? So therefore, in our case, let's draw it here. That'll be cos d, which is 1 over root 5, or in our case, I called my d alpha, so it doesn't matter what you call it. You can call it cos d, alpha, whatever you want. But effectively, we end up with cos alpha is equal to 1 over root 5. Then just do the inverse of cos of 1 over root 5. Okay, make sure you're in degrees. And you will get your value, okay, as 63.4. Okay? And therefore, we know that, the angle, so you can write angle, what's it, angle BDC. We know that is equal to 63.4 degrees, and that will be it. So again, it's a longer way to do it, okay? That question is a free marker. Obviously, you could have just put all this into a calculator at this point here. So feel free to put all this into a calculator at this point here. I decided to work it out manually, but feel free, put this all into your calculator here, and after that, you should get a 1 over root 5. And once you get 1 over root 5, yeah, just inverse cos of 1 over root 5, and it should give you your answer, okay? But yeah, that will be it for this paper. Overall, a nice paper. Maybe a few questions, which is maybe a bit tricky. Like, I think maybe the angle question on question 10, maybe you've never seen that before. But other than that, overall, a nice paper. But yeah, that will be this one. Next week, we will have the October-November 2022. We'll have the variant 2 next week, so stay tuned for that. And yeah, I will see you soon.